Okay, good morning, everybody. So there's no set of lecture slides today, so I'm working out of the notebooks. Is this thing working? I'm working out of the notebooks directly today. Okay. All right, so I want to move on to the quoting notebook. So you're going to need some of the material here in order to complete the assignment that's currently out. Oops, sorry. All right. So you've seen that when you use a command, you type in some command name, right? Then you use a space, and then you put in some options, and then you use a space, and then you put in some arguments to the command, right? They might be strings. Well, they're always strings, right? But those strings might be file names or something else, right? Now, in the previous lecture, you also saw that there are some characters that are special to the shell, right? So the question mark and the star, those are special as far as the shell is concerned, right? The star matches any sequence of characters. The question mark matches any single characters, right? If you stop and think about it for a minute, the hyphen is special as well, or the hyphen appears to be special because when you use a command, right, and you want to pass in an option, then there's typically a hyphen at the start of the option, right? And so you might guess that the hyphen is also special to the shell. And so that becomes a problem if you want to use those special characters in the name of a file, right? Or as part of a string that you want to pass the command, right? Because the shell is going to interpret those characters in a special way, right? And so in Bash, the term quoting is used to refer to removing the special meaning of a character, right? Now, the funny thing about quoting is it's not always, you don't always use quotes to remove the special meaning, right? Okay, so you want, if you're running the notebook, if you ever see this at the top, near the top of a notebook, you want to run that cell code first before running the rest of the notebook. All that does is it puts you into the correct directory for this particular notebook, right? And so if you actually go and look at your directory structure for your notes, you'll find that in the Bash directory, there's a scripts directory. In the scripts directory, there's directories for each one of the notebooks, right? And in those directories, you'll find the scripts for or you'll find the files and whatever scripts you need for that notebook. Right? So you want to execute that that cell, and that puts you in the that directory there. All right. So one way to change the special or remove the special meaning of a character is to use the backslash in front of it, right? Now you have to remember it's the backslash, right? So it's that character there, right? Backslash, right? And don't confuse that with the forward slash, right? Those are different, right? So the forward slash is the name of the root directory. It's also the directory name separator when you're using it as a sequence, when you're writing out a sequence of names on a path, right? So don't switch these two. It's very common, especially on the tests, that students will flip these two or only use one of the two for some reason for everything, right? There is a difference between these two characters. So the backslash is used in front of a character, removes the meaning of that special character in most cases, right? So it preserves the literal value of the next character that follows the backslash, with exception of the new line. And there's some other exceptions as well sometimes, depending on the context. Right, so for example, if I wanted to put a space in a file name, right, I can do that by putting a backslash and then typing a space and then the rest of the file name. Right? The backslash removes the special meaning of the space, which in Bash separates words, right? And you can now use it as part of a string. Now you might wonder, so what are these special characters, right? And it's not at all obvious what the special characters are. Right, so there's a little script that should look like gibberish to most of you. That's because it is gibberish at this point in time. Right? You won't be able to understand that for another couple of weeks. But that script there, if you run it, will actually print out all of the easily typed in symbols on a North American keyboard, right? And it'll tell you which one of those may or may not need escaping when you try to use it in the shell. Right? So when you run that, it says, no, the % sign does not need to be escaped, so it looks like % is not special. Right, plus is not special. It says hyphen is not special, which is interesting, right? Dot is not special. The forward slash is not special, right? And so on and so on and so on and so forth, right? So it looks like you can actually, these don't need to be escaped if you're going to use them as part of a string or something else, right? Now, which ones do need to be escaped? Well, the space needs to be escaped, right? Because that's the word separator in Bash, right? It separates arguments to a command. So if you want a space in a file name, you have to escape the space, right? And there's a bunch of other things here that aren't, that shouldn't be surprising. So star is here, right? Remember, star is the matches any character symbol, right? Question mark is here somewhere. There it is, right? Match any single character. It's not surprising to see round brackets here, right? So even though we haven't seen it yet, you can sort of guess that the brackets, so round brackets, square brackets, and possibly braces, right? Those all might be special to the shell, right? So the shell might want to use those characters for some other construct, and in fact it does, right? And a bunch of other characters are also special as well, right? You don't need to memorize this list, right? You just have to be aware of the fact that these characters do exist, right? And that if you want to use these as part of a string or as a file name, for example, they may require special treatment, right? Now notice that's the character that you're using to escape the special meaning of a character, so that character in itself is also special, right? So if you want to use a backslash in a name, it's backslash backslash, right? And so so the backslash is one way to escape the special meaning of a character. Right, so if we go into the directory, I'm going to do this from the shell directly. Right, so if I go into that directory that's in the that the notebook tells you to switch to, that directory, right, and you look in that directory, you'll see that there's 3 files in this directory. Right. Also, when you print them out with ls, notice that ls surrounds these file names with single quotes. Right, the single quotes are not part of the file name. Right, the ls is using the single quotes to indicate to you that there's some unusual character, one or more unusual characters in these file names, and it's using single quotes to point that out. The single quote is itself special. So if the single quote was part of the file name, it would also need to be escaped. Right? So here you can see a file that has spaces in its name. Right? Here's a file that's got an asterisk in its name. Right? And there's a file with a question mark in its name, so these are all special. Right? Suppose I wanted to output or print the contents of one of these files, right? So I would type cat, right? So for concatenate, right? And now if I just type in file with spaces in name, like that, right? And you press enter, something, you get an error, right? And you say, and cat says, there is no file called file, right? There is no file called with, there's no file called spaces or in or name, right? And that's because, when you type in that, right, cat thinks you're passing it 1, 2, 3, 4, 5 different file names, right? So it thinks that you're passing in file and with and spaces and in and name, right? So you can fix the problem using an escape character, right? So backslash space, backslash space, backslash space, backslash space, right? And when you do that, right, it prints the contents of the file. Notice what the contents of the file are, right? Avoid using spaces in file names, right? Because if you do, you avoid running into problems like this, right? Now, the unusual thing in Unix is that Unix does not disallow any characters in a file name, as far as I know. There might be 1 or 2 exceptions, but as far as I know, you can use any character that you want in a file name, including the new line character. So it's possible to have a file name that spans multiple files, multiple lines, which really causes all sorts of havoc in many scripts, right? And so in this particular case, right, so if you need to escape one of these special characters, right, the backslash is one way to do it, right? Okay, so what about file with a star in the name? So again, if you typed in file with a star in name, like that, right, you get some output, and you might think, oh, this is correct, right? I actually got some output, there's no error, right? It actually output the contents of 2 different files in this case, right? So remember that star matches anything. So it matches itself in that file name, and it also matches the question mark in that file name there, right? So that's the contents of file with a star in the name, right? And that's the contents of file with question mark in name, right? If you really want just the contents of file with asterisks in the name, you have to escape the asterisks, right? And now you get avoid using the asterisks in file names, right? If you try, if you use file with question mark in name, right? Again, you get the contents of both files, right? Because that question mark matches the star, right? And it also matches itself, right? If you just want the contents of file with question mark in name, you have to escape the question mark like that, right? And now you get just the contents of that one file there. Right, so if you have special characters in a string or file name, you can use the backslash to remove the special meaning of that character. Right? Okay, but you can do this in other ways as well. Right? And so it's called quoting in Bash because quotes are used in Bash to remove the special meaning of characters. Right? Single quotes and double quotes behave differently. So single quotes will remove the special meaning of everything in between the pair of single quotes. Right? You cannot have a single quote between a pair of single quotes. Right? So if there's a single quote inside your string, you can't single quote it away. Right? You have to escape it. You either have to use an escape character, the backslash, or double quotes. Right? So single quotes remove special meaning of everything. Right? So if I single quote, well, let's do it from here. Right? So if I single quote file with star in name, you get just the contents of that file. Right? If you single quote file with question mark in the name, you just get the contents of the file with question mark in name. Right? And if you single quote file with spaces in name, you get just that one file as well. Right? So single quotes removes the special meaning of all characters inside the string. Right? Okay. Double quotes are more commonly used than single quotes, especially when you start to write Bash scripts. Okay, so inside a Bash script, you often need to escape the special meaning of a character, right? And so double quotes are often used because double quotes preserves the literal meaning of most characters, right? But some of the special characters still work. Oh yeah, right, there's an error, sorry, I never did fix this. Notice that in the text for this particular file, right, there's a backslash, right? What does a backslash do? Well, the backslash is special. So in order for Jupyter to actually display the backslash, you need backslash, which I forgot to do. So that's what it should look like, right? So the backslashing doesn't just affect things like Bash, right? This is also affecting Jupyter, which is not Bash, right? It's Jupyter. So Jupyter is also using the backslash to escape stuff. Okay, so the $, which you'll see either in the next lecture or the one following that, could be the one following that, right? This thing's used everywhere because the $sign is used to access the value of a variable, right? And so it's not surprising that it's not that surprising that you want to let the $sign do what it's supposed to do, access the value of a variable, right? When you use it inside of a pair of when you are quoting it, right? So the $sign still behaves the way it normally does. The backtick, which we don't use in this course, but the backtick keeps its special meaning, right? The escape character, the backslash, also keeps its special meaning. And the question mark sometimes keeps its special meaning, right? This says that it keeps its special meaning if file history expansion is enabled. You don't have to worry about that, right? That's just there for completeness, right? Now, the backslash doesn't work the way you expect, doesn't work 100% the way you expect it to, right? So its meaning is also modified inside double quotes, right? So it escapes, the only characters it actually escapes are the ones that are listed here, right? So if you want to use the $sign as the $sign inside of double quotes, it's \$, right? If you want to use the backtick on its own, right? Instead of having its special meaning, it's backtick, right? \\, right? If you want the double quote to appear as the double quote inside of a double quoted string, you escape it as well, right? So \double quote. So double quoting is very common in Bash. It prevents this thing called word splitting, which we'll talk about later, right? It also prevents file name expansion while still allowing you to access the value of a variable. We're going to talk about this when we get to talking about variables in Bash. Right? So for now, if you've got a file name with unusual characters in it, you can also double quote them. Right? So file with star name, double quoted, that works. Right? File with question mark in name, double quoted, that works. And file with spaces in name, double quoted, also works. Right? So we're going to talk about these other kinds of expansions as we progress through the course. Right? So there's quoting, right? So remember, if you want to escape a single character, you can usually put a backslash in front of it, right? If you have special characters, you can get rid of the meaning of all of them with single quotes, except for the single quote itself, right? And if you use double quotes around your string, that suppresses the meaning of most special characters, but not all, right? And in particular, it allows the $ to keep its special meaning. Right. Okay, so any questions about quoting in Bash? Right, you'll need to use this because some of the file names or some of the directory names that you're working with in assignment 1 have unusual characters in them. Right, what do they have? Some of them have spaces. I think one has a single quote in it, and I think that's mostly it, I think. Right. All right, so next notebook is actually working with files. Right, and so almost everything you do from the command line is going to involve touching one or more files of some kind, right? Because files are where information is stored on your file system. So you're going to want to know how can you create files, or how can you create simple files anyway, right? Simple text files, right? How can you rename them? How can you move them? How can you copy them without having to pull open your file system, your graphical user interface like a file manager of some kind, right? You can do all of this from the command line. Okay, so in Unix, there's a programming metaphor that says everything is a file, right? And so in Unix, the everything is a file model is a simple abstraction for performing input and output, right? So input meaning how can you read data, output, how can you write data, right? Regular files, directories, your disk drive, right? Your terminal, right? Even some networking, right? All of these things are all accessed in the operating system the same way, right? In other words, for all of these things, you can think of the operation as writing to a file and reading from a file, right? Type something in, that's like writing to a file, right? That happens to correspond, typing something in is like reading from a file, right? Printing something to the screen is like writing something to a file, right? Where the file happens to be your terminal, right? And so in Unix, a file is considered to be just a collection of bytes. It's actually considered to be a stream of bytes, right? So there's one character followed by another character, followed by a second character, followed by a third character, and so on and so on and so forth, right? So information is just a sequence of bytes. All right, you want to be in that directory for this notebook, right? Run that little cell, and then you're ready to go. Oh, here we go. So in Unix, any character can appear in the file name except for the /, right? The // is reserved by the operating system because it's the path, it's the directory separator for path names, right? Similarly, you cannot use the null character, so that's \0, which is the numbers, which is the numeric value 0, right? Not the character 0, right? There's a difference between the character 0 and the numeric value 0, right? So the numeric value 0 also cannot be used in a file name, right? The reason that can't be used in a file name is because later on in the course, you're going to learn that's the character that's used to mark the end of a string, right? Okay, so file names are case sensitive. So ABC is different than big A, big B, big B, big C, or big A, B, C, right? So those are different. If you come from Windows, whether you know it or not, right? Windows does not consider case in the file names to be important, right? So file1.png is the same as file1.bigpng, right? In a Windows file system. Mac, everything is case sensitive. Right? Anything beginning with a dot we saw in the last class, that's considered to be a hidden file. Right? Most commands will not process those files by default. Right? So for example, ls will not list the hidden files by default. You have to ask it to do so. Right? Okay, so many of the characters, many of the symbols that you can type in on a regular keyboard are considered special. Right? So it's generally a good rule to not use those characters in a file name. Right? So if it looks like a symbol, you should probably avoid using it in a file name. Right? That will save yourself and any programs trying to access those files. It'll save them a lot of trouble. Right? Some programs actually won't work properly if you do put funny characters in a file name. So for example, Eclipse on a Mac does not work properly if you put a colon somewhere in a directory name that Eclipse is trying to access. Right? And so for example, if you made a directory like courses : 2024, right? And you try to feed that to Eclipse somehow, maybe as part of your workspace path, right? Eclipse will barf on that. Right? It can't handle the colon properly. It's also generally a good idea to avoid white space in a file name. Right? So it's very common, especially if you come from an operating system like Windows or Mac, to name your files with spaces in it, right? Because that's the way we write English. You then have to deal with the fact that the space is a special character in Bash. So it's often good practice to, instead of using a space, use an underscore instead. Right? But spaces are pretty common, so you kind of have to deal with these. You kind of have to deal with the space. Right? Now hyphens, you should never put that as the first character of a file name, right? Because of that, right? When you put in a hyphen as the first character, most Bash commands will interpret that as some kind of option, right? So instead, if you have some weird file name that has a hyphen in front, right? So some command and then strange file name. Right? Most Bash commands will try to interpret that as being an option, right? And then the command will barf because it'll say there's no option called strange file name, right? So you should avoid hyphens as the first character of your file name, right? You can, I mean, if for some reason there are hyphens as the first character of your file name, you can deal with them, but now you have to treat them specially, right? And because of the way that, because of the fact that these special characters exist in Bash, if you search online for advice on how to do something in Bash, right, almost all of that advice, right, eventually gets down to the point where you have to do something in a certain way so that the special characters are treated correctly when you use them in a file name of some kind, right? And so a lot of the advice you'll see on the internet is there because you have to deal with the existence of these special characters. All right, so how do you make a text file from the command line? Right, so you can always use an editor of some kind. Right, so there are editors that run in your shell directly. I'm not going to show you how to use them because it's really kind of not pleasant to use most of those. If you want to, though, you can learn about VI or Vim and Emacs. Right. I guess some people still use them routinely, but it's a bit uncommon nowadays. Right? Nowadays, most people, most programmers anyway, have access to a Windows-based, some sort of windowing environment, and so you can have some sort of graphical text editor. But if you want to do everything from the command line, it's still possible to do. So you can create a new file using the command called touch. Right? So the touch command creates one or more named files if they do not already exist. So I have to switch into this directory in my shell because I probably files? Because I've probably messed up this. Oh no, it looks okay. All right. So this says it should list only dir1, file1, and a.text the first time you run this. So is that true? dir1, file1, a.text. I've also got words starting with a, but that's okay. Right, so those are the only files I have in my directory. Okay, so if you run the touch command, right, and you pass in the name of some files, right, if those files exist, sorry, if those files do not exist, then touch will create empty files for you. Right? So if I run touch file2, file3, oh, sorry. So touch file2, file3, like that. Right? If a command produces no output, that normally means the command has run successfully. Right? So that's another Unix thing. Right? A Unix command that produces no output probably has run to completion successfully. Right? A Unix command that produces output, right, is either designed to produce output or has encountered an error of some kind. Right? So if you see nothing, that's good. Right? Something has happened. Right? If you type in ls, you'll now see that there's a file called file2 and file3. Right? If you look at the size of those files, oops, sorry. Sorry. What do I want? I want L big S, like that. Okay. So if you look at the size of file 2 and file 3, right, you will see that they are 0 and 0. Right? So they're empty files. There's nothing in them. File 1 is also empty, but it was already there. Right? Notice the modification time. Right? Oh, someone has started their office hours. Why does my computer think it's 5:47? I don't know why my computer thinks it's 5:47. Right? The date's correct. The time is wrong. Right? And so that's the modification time of the file. Right? And so that was the time at which the file was last changed. Right? So when you make a file, that's changing the file. Right? So they now appear. Oops, sorry. Okay. If the file already exists, then touch updates the access and modification times of the current file. Right? So there's file 1, right? It was last modified last term. Right? If I now touch file 1, right? File 1 now says, or the information for file 1 now says that it was modified at, well, 5:49, which the minute's not even right. I don't know what's going on. Right? So I'm not sure what's happening here. But my computer is confused. Right? Okay, so there's touch. So touch is the easy way to make a new empty file. Right? Occasionally it's useful to mark that you've modified an existing file to update the modification time of an existing file. Right. All right, so makedir makes directories. So here, the echo command, right, will print out a string. Right? So echo some string, right, before makedir. Right? Okay, so the and operator we're going to see a little bit later in the course, right? But in this particular example, right, what and does here is that it will run the ls command, assuming, if the echo command ran successfully without error, right? If the echo command produces an error of some kind, right, then the ls command will not be run. Right? And so that's what and is doing here. We're going to see and later in the course. Right? So this should print before makedir. Right? It will then make the directories dir2 and dir3. Right? It should then print after makedir and then list the contents of the directory. Right? So if we run that, right? So before makedir, we've got these files here. Right? After makedir, we've now got a dir2 and a dir3. Right? Those directories are empty, so there's no files in those two directories. Right? Now, it's not uncommon when you're making directories that you actually want to make a sequence of directories. Right? So, for example, you might want to make dir 2024, then a month, and then a day, right? If you want to organize your files by date. Right? That's pretty common for people who do things like photography or some sort of graphic design. Right? They often name their directories by the date. Right, so if you try to do something like this, so I want to make XX, inside XX I want YYY, and inside YYY I want ZZZ, right? That's not going to work, and makedir will complain, right? So notice that you get output on this command, right? You get output because it's telling you, because there's an error, right? The error is not particularly helpful, right? So when you read the message, it says, cannot create this directory, no such file or directory. And you say, well, yeah, there is no such file or directory, I want to make it. That was the whole point in running makedir, right? And so the reason it's complaining is because it's trying to make the directory ZZZ inside of that directory there. Right? That's what it's actually trying to do in this example. Right? And of course, the directory XXXYYY does not exist. That's what it's complaining about. Right? Now, you could, right, manually create the directories in order. Right? So make XXX first, then make YYY inside XXX, and then make ZZZ inside YYY. Right? But there's a much easier way to do that. Right? The -P option creates all parent directories as needed. Right? And so this makes the directory makes ZZZ, right, inside the parent directory YYY, inside the parent directory XXX. So it creates all three of them for you. That, right? The tree command is not installed. It may or may not be installed in your Linux installation, right? So if it's not there, a modern Linux installation will tell you how to install it. Right? But tree produces a graphical representation of your directory structure. Right? And so now you can see, right, there's your directory XXX, right? And inside that is YYY, and inside that is ZZZ. Right? That's also how, the tree command is also how I created the directory structure on the assignment for you. Right? All right, so you can use touch to create a file, but that's not the only way to create a file. Right? So many commands will write their output to a file. Right? Most commands write their output to the terminal. Right? It directs it to what's called standard output. Right? So in Bash, you can change where the output goes by what's called a redirection. Right? So many commands produce text output, and by text output I mean it prints it to the screen. Right? If you don't want it to go to the screen, but instead you want it to go to a file, right, you can use the operator that looks like the greater than sign. Right? It's only one greater than sign. Right? So if you write a command like cowsay, moo, right? That sends its output to the screen. Right? More precisely, it sends it to what's called standard output. Right? If somewhere after the, well, actually not necessarily, well, if somewhere in the command in your line, right, you have this operator here, right, it will redirect it to the file that you specify here. Right? Now, when it redirects the output, right, the output no longer goes to the screen, right, instead goes to the file. Right? So if I type in that, press enter, right, no output appears on your screen. Right? Instead, you'll see that there's a file called moo.txt. Right? And if you print or cat the output of, the contents of moo.txt, right, now you'll see the output that was generated by the command. Right? So a redirection will let you send the output of a command, which normally would go to standard output. It allows you to send it to a file. All right, so there's also a greater than operator. Right? So the single greater than on its own will overwrite an existing file, and it won't warn you. Right? Won't warn you. So there is moo.txt, right? So if I use cowsay to do something else, how about boo? Right? And I redirect that to moo.txt. Right? Cat moo.txt, right? Notice that it's overwritten the contents of the file, right? So a redirection will always, with the single greater than will always overwrite a file, even if the file already exists, right? And it doesn't warn you, right? Notice that when I did the redirection here, right, it simply overwrote moo.txt and it didn't tell me that it was going to do so. Right? So this will overwrite an existing file. If instead you would like to add the contents to the end of an existing file, right, so append the contents, right, then you use greater than. So if we now append zoo, right, Now you get whatever was there before, right, followed by whatever the output of the last cowsay command was, right? So the double greater than sign appends to the end of a file. Right? And so we're going to look at redirection in more detail in a later notebook. Turns out you can redirect regular output to a file, you can redirect error output to a file, right? And if for some reason you need to direct input a file into a command, there's also a way to do that as well. All right, so you now have the ability to create some simple files, right? Simple text files. So once you've created them, what can you do with them? Well, you might want to move them around, you might want to copy them, you might want to remove them, right? So the mv command is the file that moves or renames a file, right? So there is no rename command. It's all done through mv, right? So mv, some file name to some other file name, some new name, right? Changes the file name of that file so that it becomes that. So it renames the file. Right. So if I run this here, so touch a file, so that makes a file called a file. So let's do that. What do I? Oops, sorry. Alt. Where do we go? Sorry, I'm in the wrong notebook now. There we go. Okay, so there is no a file, so I'm going to make a file called a file, like that. Right, there's a file. Right, if I decide that I want to call it something else, then you use mv. Right, so mv, a file, b file, ls, and now a file is gone. Oops, sorry. Right, a file is gone, and instead its name is b file. Right, just to convince you that the contents of the file are not modified. Right, let's look at what's a. So a.text has just got a bunch of words that start with a capital A. Right, if I move a.text to a words.text, like that, right, a.text is gone. I don't know why it's doing that. And a words.text now appears, right? But a words.text, that's just the contents of the old a.text, right? So it simply changes the file name. I'm going to set it back because I may need it. Right, so if you want to take a file and move it somewhere else, right, it's also mv, right? So if you pass in some directory, right, it could be an absolute path, could be a relative path, right? So if you move a file into another directory, right, that takes the file and actually moves it into another directory, right? So here I'm going to take the file b file, right? I'm going to move it to the directory dir1, right? And also rename it to C file, right? So this is actually doing two things, right? It's moving the file B file into the directory dir1 and renaming it C file. Right? So again, there's B file, right? If I look in dir1, there's a text and a words.text, right? So if I just wanted to move B file into dir1, I would type in move B file dir1. Notice B file is gone, and inside dir1 is B file. Right? If I want to move B file back into the current directory, right, move dir1 B file to here, right, dot. Right? And B file is back, and if you look in dir1, right, it's no longer in dir1. Right? The example in the notebook moves and renames. So move B file to dir1 and rename it to C file. Right? B file is gone, right? And in dir1 is now C file. Right? So to rename a file, right? It's move, file name, new file name. Right? To rename a file and move it to another directory, it's move, directory, new file name. To just move the file to a new directory, it's move file name to some directory name, right? So in other words, if the path ends in a directory name, it moves the file to that directory. Like that, right? So to move fname without renaming it to a different directory dir name, right? It's move fname dir name, right? The dir name can be arbitrarily long, right? So similarly, fname can be arbitrarily long, right? So for example, I can move dir1 b file. Is it still, where to go? Oh, it's c file now, right? See, so I can move this wherever I want, right? So I can move it into my home directory. Well, let's just move it into my home directory like that, right? So remember, tilde on its own is my home directory, right? If I look in dir1, right, it's gone. If I look in my home directory, so ls tilde, right, you will find, well, a bunch of junk, because that's what it is, right, and C file there, right? So the directory can be arbitrarily long, right? So similarly, I can move it directly now as well, right? So from my home directory, I'm going to move C file into my home directory. I don't know, where do we want to put it? dir03. Sorry. /dir03. Is there anything here? No, right? So if the destination ends in a directory, it moves the file into that directory, right? If it ends with a file name, right, it also renames. Where did, here. Oh yes, just like with redirection, right? Renaming or moving a file to an existing file name overwrites the existing file, and there's no warning, right? Okay, so what do we have here? We got file 1, file 2, and file 3, and moo.txt. I'm going to move moo.txt onto file 3. Like that, right? Moo.txt is gone. File 3 is here. If you look at what's inside file 3, right, it's now the contents of moo.txt, right? Whatever was in file 3 is now gone, right? So you get no warning that this is going to happen, right? So the copying, the moving, and the deletion commands in bash, right, they all will overwrite or remove files without warning the user. Right? So it's not like Windows or Mac where it says you really want to overwrite this file or something like that, right? It just overwrites it. Now, okay, so if you really want to prevent the overwriting, or sorry, if you want the command to ask you, do you want to overwrite, right? There's an option -I, right? So I'm going to try to move file 3 onto file 2, right? And it will now ask you, do you want to overwrite file 2? Y is yes, N is no. So I'm going to say no, right? And file 2 and file 3 are left unchanged, right? So file 3 does not get moved or renamed, right? File 2 does not get overwritten. Right. Back when I was learning how to use, so back when I was a computing science student, which was a long time ago, CAS lab was a Linux, wasn't even a Linux lab, it was a Unix lab, right? And so all of these, all the moving, renaming, sorry, the moving, the deletion, and all the copying commands, right, they were all aliased to their interactive versions to prevent students from accidentally overwriting their files, right? That's no longer the case, right? So on your Linux or Mac systems, right, all these commands will overwrite by default without warning the user. Okay, removing, do I ask you to remove? I don't remember if I asked you to remove everything on the assignment. So when you remove a file in Unix, it's permanent, right? So file deletion is permanent. There is no guaranteed way to recover the contents of a deleted file, right? This is baked into the design of the Unix operating system, and it's considered to be one of the problems in the design of Unix, right? So be warned, right? If you're going to use RM on your computer, right, on your Linux or in your Mac from the command line, right, it will permanently delete your files, right? So to remove a file, just remove file name, right? Okay, so here we're going to create a bunch of files, atext, btext, ctext, dtext, etext. There they are, right? You can pass in one file name, or as many file names as you want. It will try to remove all of the files that you pass in, right? So remove atext, btext should remove, where's little a? Should remove that and that, right? And it does. right? And they're really gone. There's no way for me to easily get these back, right? This is dangerous because you've got these wildcards, right? So remove star.txt will remove every file that ends in txt, right? And notice they're all gone, right? That thing, word starting with A, right? It now shows up in red, right? This thing here is actually what's called a soft link. So it's actually pointing to, or was pointing to, the file a.txt, right? A.txt no longer exists, so the link is no longer valid, right? So that soft link is dead. Yes?
When we do this, does the file go into the trash?
No, it's gone. There's no trash. It's gone, right? It's gone forever, right? There's no way to recover it. So this is particularly bad. So on most of your computers, you probably don't have root access by default, right? So root access is the access level that you have when you're an administrator of the computer, right? Typically on most modern Linux operating systems, you have to specifically switch to the root user account in order to do anything, right? If you have root access, you can delete your operating system, right? So you can go into your root directory, right? So I'm in the root directory, right? Here's where all the operating system files start from, right? If I had root access on this computer, I can delete everything inside the file system, right? And the computer would probably crash, right? So to nuke everything in your file system, you would write remove star.star, right? Actually, you would write remove -r star.star. So R is recursive, right? If it's a directory, it recursively removes the contents of the directory, right? Let's do it for fun. Okay, so that doesn't work for me, right? So it's going to so this one complains, right? Because I don't have root access at this moment, right? So I can't actually modify the operating system files, right? For most of you, this shouldn't work either. Don't do it, right? So don't do it, right? Okay, question.
Yeah, how come it says, if you don't have root access,
Yeah.
let's say you have no permission, whatever it says, you go to files directory.
Yeah, so it should say, there you go. So that's what you're asking for. Yeah. Hey, yep, we're done.